Hello and welcome to another tutorial. We're looking at the operators in Java, and we are looking at the simple assignment operator. So assignment operator is just the equality sign, right? One of the most common operators that you will encounter is the simple assignment operator, equality. And just want to mention that assignment is different from equality. So one equal sign means this is an assignment operator. And the contract of the assignment is that whatever is on the right hand side of this operator, equal sign, will get evaluated first, and then the result will be assigned to the left side. What this means is that if you have something on the right hand side of the assignment operator that doesn't return anything, let's say you're calling a function or method that returns void, for example, or whatever it returns cannot be implicitly converted to the type on the left hand side, then you get a compiler error. So the compiler error happens when the types on the left and right don't match, right? Remember, void is a valid type for the return of a method, but it's not a valid type for a variable, right? You cannot say this variable is void. In C++, we have something called void pointer. So in C++ also you cannot have a variable of type void, but you cannot have a pointer of type void. But in Java we don't have pointers, so we cannot have any variable of type void, right? You saw this operator in bicycle class. It assigns the value on its right to the operand on its left. Int cadence equals 0. Remember, equals means assignment operator. Any of these symbols, plus, minus, equal, these are all operators. Although Java doesn't allow you to overload the operators by default, these symbols, these operators eventually translate to some sort of method call or function call. If you're familiar with C++, object-oriented programming in C++, these things make more sense because you can pretty much overload the assignment operator for a particular class. And I will show you in this lecture an example of overloading the assignment both in Java and C++. Alright, so we're defining variables, and then we already have looked at this definition and initialization of the primitive types, right? Again, we looked at this in terms of initialization of a variable. You declare its name, declare its type, and then you initialize with the value. But in fact, what you're doing is using the assignment operator, and the Java compiler knows how to translate this assignment operator into some sort of bytecode. This operator can also be used on objects to assign object references, as discussed in the section creating objects, right? So let's create a new class here, assignment operator. Let's have a main method. So I'm going to create a method called test1. All right, and then public static void test1. So what do we want to do here? We want to look at have a closer look at assignment operator. Assignment operator is equality, equal sign, right? One. Just again to reiterate, assignment operator is one equal sign. Equality operator is two equal signs, right? And this can translate either in basically value. If you use the equality sign on primitives, it translates into value, basically equality of the value. It checks the values. If you use the assignment operator or the equality operator on object references, you get it checks the memory addresses or the pointers, right? And then if you want to translate that for object reference into a logical operator, as you probably can guess, you have to override the dot equals, right? Equals method from the object class. That's something to note. We will come back to this equality operator. For now, we're looking at the assignment operator. So if we deal with primitives, so category 1 is primitives, and assignment is in the context of either initialization, right? It's very intuitive what this means. Int a equals 2. We are declaring a variable, which means we're telling the compiler, hey, this a holds the memory address of a variable of type int, and go ahead and initialize it with 2. Or we could say int b, we just declare it, right? And then we say b equals 5, and now we're using the assignment operator. Now if you're familiar with C++, you know that in C++ this declaration, if you're dealing with objects, classes, if you declare and immediately initialize, this calls the copy constructor. However, if you do this kind of declaration and then assignment, then what happens here is that in C++, if you declare an empty object, you don't give it any parameters, any object has to have a default no-R constructor, right? And we know that in Java it's also happening, but the difference is that in C++ you can also construct an object on the stack, which means you don't actually use the new keyword, right? In Java we have to always do a new keyword. But then so this calls a constructor. So whenever you declare an object, whether you immediately initialize it or you initialize it later, you have to, the compiler has to call some sort of constructor to construct the object. Constructing the object just means you allocate memory, enough memory to hold that object, right, to the data for that object. And then when you do, after you construct the empty object, you use the assignment operator. It actually calls the assignment operator. So this is a call to operator equal method, right? And it takes some parameter, and I'll show you an example. But for now I just want you to understand what's going on with classes. What is the difference between initialization, if you initialize something, and then what is the difference between actually using the assignment operator. Now for primitives this doesn't matter, because int b, we said that in Java when you declare a local variable it's not going to be initialized. So in Java local variables are not initialized. What this means is that this b doesn't hold any value. This is well, actually it uses the value of basically 0. So if we don't initialize it and try to print it to the console, for example, this is going to give us compilation error, because it says that local variable has never been initialized. So again, this means that local variables don't get the default values, right, are not initialized. When we say a variable is initialized, meaning it gets the default value. And we said that Java provides this guarantee that the class variables which determine the state of the object or the state of the class, right? Remember, to reiterate or to refresh your memory, a state of the object means non-static variables or fields, right? And then a state of the class means static fields. And Java provides this guarantee that whenever a class is loaded in the memory, or an object of a class is constructed, an instance of a class is constructed, all the static fields and non-static fields will be initialized. If you haven't already initialized them when you wrote the source code, then they will get their default values, which means primitives get their default values, reference types become null, right? That's the default value. All bits are 0. So any local variables does not get initialized by default, because as soon as you leave the method, they get popped out of the stack. So if you declare a parameter or variable like b and you never use it, then there is no point for the JVM to actually allocate memory for it or push it to the stack. But then Java is careful, and it sees that you declare something, you never initialize it, but you intend to use it. That's why it gives you a compilation error. Now in C++, you don't get an error, it just gives you a garbage value. All right. So let me go ahead and create a new C++ project. So a new C++ project, C++ managed build. I'm going to use the internal make for that the C++ CD, the Eclipse offers. And then I'm going to start with the executable. Let's call this dev.java C project. And then next, and then let's just keep the release mode. All right, so dev.java C project. We have this CPP. Let's see if we can build it. And it's discovering the compiler build settings. So it probably takes a little bit of time. Now it finds all the build tools that my operating system offers, right? And then now it created the binary. so the binary here, and it's a 64-bit build. So now I can go ahead and run this, right? And it just prints hello world to the console. So my C++ project works. And the fun thing here is that I'm going to put these side by side, and I am going to go full screen. So let's see. We're going to have main. In main, we're going to have, I'm going to remove this std because I don't like to include the entire namespace. And then I'm going to say void test1. And we're not going to return anything from main. There is no point. And I'm writing my functions at the top in the global scope. That's just because if you put them at the bottom, you have to give the prototype at the top. All right, so in main, we're going to call test1 in C++. All right, let's see. So int a equals 2. This is valid, right? And then std cout a, right? So this is, and then semicolon. And we can also say std end l. So we declare a variable a equals 2. We immediately initialize it, right? So if we build and then run, so where is my terminal? Let's put this somewhere here, for example. So 2, we get 2, right? Same here. If I do a sysout a, I get 2. Let's run the Java. We get 5. 2 and 5 because we are also printing out b, right? So, but what if I say int b and then std cout b? Note that what happens. So this is the Java code. Int a equals to cout. We're printing to the console, right? A, and then int b. We're not initializing it, and then print b. And in Java, we immediately get a compiler error. So proceed, unresolved compilation problem. The local variable b may not have been initialized. What about C++? If we build and it builds fine, it gives us a warning, right? Variable b is uninitialized when used here. So, and you see the default compiler parameters that my Eclipse setting uses is -w all, which means show all the warning and treat them as warnings. You can also say -w error, which means now treat all warnings as error, right? But here the default is just treat them as warning. But if I run this, it's going to work, but it's going to print some garbage value, which is expected, right? So this results in garbage value, right? Now we want to look at the basically we want to look at the operator assignment to see how it works, right? The assignment operator. So let's create a class vector, and then let's say double x y, and then let's have a constructor public vector, and then double x double y, and then this dot x equals x, this dot y equals y, right? This is our Java. And then so we already, I guess, defined the vector in another class, I believe. Yeah, and these are in the same package, so we cannot use this kind of stuff. Let's see if we can make this private. I don't think private is allowed. Illegal modifier. So for classes, you cannot do private. So let's say something like vector 1 or vector 2D, for example, right? Vector 2D. And then the name of the constructor should be the name of the class, vector 2D, right? And then we can also have a toString method. So source toString, and then boom, that's it. That's all we need. Obviously in C++, we have to do some other stuff to get the toString working on the console. But for now, let's go with this, and then let's have a new method, test2. So in test2, we're going to just create a class of, so let's put this here, public static void test2. All right, so we're going to create a vector 2D. v1 is new. We always have to use new operator, vector 2D, and then 1.1, 2.2, and sysout v1, right? So this is how we are creating. Why do we still have compiler error? So this B is still not initialized, so let's initialize it. That's fine. And then let's run this. Everything works fine, right? So we created our object and it works fine. Now, obviously in Java, we cannot say vector 2D v2. This is not allowed. This is actually allowed, but this means v2 is null reference, right? Because v2, everything has to be created with a new operator, and then this new operator returns a valid reference. So if I do a sysout v2, this returns back as null. Or basically it just tells me you never initialize this. Let's initialize it with null. That's still fine. You have to explicitly initialize local variables and null, right? And now the thing here is that in C++ you can actually have an expression like this, vector 2D, and the meaning is that you're assigning or creating this class object on the stack. Now we're going to, and what I want to show you is that even if you have a default no-arg constructor, remember when you add a constructor that takes parameters, you lose. The compiler doesn't add the no-arg constructor, but you can explicitly bring it back. Now note that even if I have my class has this no-arg default constructor, I still cannot have a reference like this. It never gets initialized, and I get the error for the local variable v2 was never initialized. Anything in Java has to be created with a new operator, right? And then the other thing in C++, it's not like that. So let's create a class. So class vector 2D, right? And then note that in C++ you have to use the semicolon. You have to use the semicolon at the end of the class scope. It's just something that a compiler needs to know, because after that you can have a scope which is a global scope which is outside the scope of the class, whereas in Java anything has to be in the scope of the class. There is no meaning of the scope outside of the class, right? That's why in C++ you have to have this semicolon. And now IDEs automatically add this. For example, in Java, when I create a scope, curly brackets, and then I do this, it just adds another curly bracket to close it. Here, if I do, it does the same thing, but if I say class, for example, xyz, and then open, it automatically closes with the semicolon, because it knows that in C++ you have to do this, right? And then we're going to have a private section, for example, and in C++ classes, the members are by default private. In Java, the default is package level access. So that's another difference. So we're going to say double X and Y, right? And then public, we're going to make the constructor public, vector 2D, and then double X, double Y. We're passing these by value. And then we're going to use an initializer list y, and nothing else in the constructor, right? So this is one way. And then what I'm going to do also, I'm going to have the vector 2D, nothing, and then I'm going to basically say that if there is no, this is the default constructor, x initialize it to 0, y initialize it to -1. All right. So let's see if this compiles. We have warnings, and the warning is that private field y is not used. So we're not, these are private by default, and we're not using them right now at the moment. So that's how you can create an equivalent class. And then what happens here is that so let's look at the test2. So let's create our test2. And what I'm going to do, by the way, I'm going to do a sysout, also print something to the console. So sysout vector 2D. I just want to make sure that we get notified when this method is called. and also sysout vector 2D with no args. This is a default constructor. And now if I create a class, obviously it calls the constructor vector 2D called, right? And if I just say new vector 2D, this is a no arg constructor. I have to explicitly call it if I want to construct, and then you see the other one, it says vector 2D call, right? So that's okay, and then we can do a sysout here. Yeah, so it works default. You have to basically call the new to create the object, otherwise this reference becomes a null reference or it's not initialized. Whereas in so basically, let's comment this out. In C++, things are a little bit different. Test2. So test2, if I say vector 2D v1, right, and then std cout v1. Let's make these public. So I want to access these variables or fields public. v1.x and then space and then v1.y and then std and l. So if I build this builds fine, which means it didn't give us any error about v1 is null or something. Now let's see if we can run this C++, and we get 0 and -1. So obviously it's calling this default constructor, and we can test that by doing a print std cout. We're going to call this, and then std and l. Same here, but this time this is the constructor that doesn't take any parameters, right? So if I build this again and then run this, as you can see, it called whenever it realized the compiler saw this expression vector 2D v1, it assumes. So in C++, that's a very major difference between C++ and Java. In C++, it assumes you are creating the object. So it doesn't mean that v1 is null, right? It assumes that you're creating the object on the stack. So that's the main difference, on the stack. And when you just declare a variable of this type, the compiler goes and calls the default no arg constructor. Now I can call the other constructor, that is still fine, right? If I pass the parameters of the constructor, it behaves exactly like Java. Yeah, and then if you really want to make it similar to Java, you call you use the new operator, new vector 2D, and then remember new returns a pointer, and then you have to kind of go with the arrow operator. All right, so again, another difference between C++ or Java. In the future lectures, I will dive deep into the main differences between C++ and Java when you're doing object-oriented programming. And then when you allocate on the heap, you have to manually do the memory management. So in this case, we don't really need to do memory management because we're not basically managing any resources, but it's a good practice to call the delete on v1 because when the main method terminates, the program returns back all the resources that it was holding to in terms of memory and other resources to the operating system. So in this case, it doesn't matter if we delete, but in reality, it's always the best practice to do memory management. So we still use the new operator. We call whatever constructor we want. And then and now I'm calling the default constructor. Previously I was calling the non-default argument, which takes some parameters, right? And 1.1, 2.2, but the difference here is that we are treating this becomes a pointer, right? And then now we see what we can do is that we say that auto basically v2 is dereference v1, and then we use the v2 dot. You can do this, you get the memory address and dereference it to get the actual object, and then you go ahead and use it. So it's complaining. All right. So the reason is that I'm using auto, but I didn't set the standard for my C++ compiler, but that's fine. It still works, right? So you dereference it. Now v2 behaves exactly like this reference that we get in Java. You can call the dot operator. Now the last thing I want to say is that how to overload the assignment operator. So overload assignment operator in Java. In Java, you have to implement the public static with the type of your class, vector 2D. So the method is called valueOf, and then you do whatever you want. Let's say I want to get to an array of double values, which has 2 elements, and then I'm going to return new vector 2D, basically values at 0 index, and then values at the first index. So this is how I overloaded the assignment operator in Java. So note that this only works for Eclipse operator overloading plugin, for Eclipse IDE. But if your IDE supports operator overloading, then you can figure out how to overload the assignment operator. In Eclipse, the way you overload it, or you tell the Eclipse Java compiler how to bind a call to the assignment operator for a particular class to the valueOf method, right? So now if I say vector 2D, v3 is new double, and give it an array of 2 elements, right? So new double -10, -20. Note that I'm creating an in-place array, and then I'm immediately initializing it. So, and we saw this syntax before. So instead of creating the array and then give it values index by index, you can do an in-place creation and initialization. Note that you cannot say the name of the array, the size. You cannot say the size of the array. The size will be inferred from the number of elements that you put in. And note that I'm not getting any compiler error, because the Java compiler realizes that if I have a double array and assign it to a type, reference type of vector 2D, it binds this call to the assignment operator to this valueOf method, and then the return type matches. And know that this has to be a static call, because it's in terms of creating the state, right? So if I do a sysout v3 and run this Java program, and now I get my vector 2D. So there was a call to vector 2D double x double y, right? So this call. So this assignment operator, so again, assignment operator means the right hand side will be evaluated, and then it's going to be assigned to left hand side. Overloading of the assignment operator means the types of the right hand side and the left hand side don't have to be the same, right? In general, if you, for example, for primitives, obviously the types should be the same, or some sort of implicit conversion should be possible. Otherwise you get a compilation error. That becomes more difficult for objects, because sometimes you just want to assign some number to a object, and you want to somehow call one of the constructors. So that's how you can overload the assignment. Now note that in Java it binds to the valueOf. In C++, this syntax, this line actually binds to the copy constructor, not the assignment operator. But then I can I do this v3 equals this still works. And if I run this still calls the result is exactly the same, because this was null. But then when the compiler sees the call to the assignment operator for type vector 2D, and the right hand side is a double array, it just calls this method valueOf. That's how. But in C++, this results in a very different thing, right? So I just want to quickly show you. So in order to overload the assignment operator, we say that we're returning a vector 2D type. I'm going to put it on the public section, otherwise you cannot use it. So it's public, and then operator equals, and then we're going to get a double array, right? Double array values. And what are we going to do? So we're going to return vector 2D, and then values as at index 0, and then values at index 1. So we are getting some syntax error. Let's see what the error is. Use of undeclared identifier values. Let's just see if we can do a pointer, for example. So where are we making a mistake? Vector 2D operator equal, and then let's spell this again. This spells fine now. I guess it gives us a warning about this auto type. So let me just go and quickly change the standard of my C++ project. So properties, C++ build, and then settings, and then the compiler dialect. Let's set it to C++ 14, and hopefully this warning will go away because auto is part of the standard. Yes, and this works fine. So we are passing, and we're not telling how many elements. The assumption is that at least 2 elements are present, otherwise things go bad. But then let's see what happens when we say that vector 2D v3 equals, now we are doing some assignment, and we're telling it, so I can say double array or double x or values array is 1 point or -10, -20. So I'm declaring an array, I'm immediately initializing it, and I'm assigning that to values. And then let's also add a print or to a string. So let's void to a string. Let's have this v.x, v.y, maybe a comma here. Or here we have to use this. Remember, this is a non-static. Okay. All right, so looks good. Oh, this is a pointer, so we have to use the arrow. All right, we're still getting an error. So the question is no viable conversion from double 2 to vector 2D. Let's see, double 2. Let's see. So we're going to give it a pointer to double, and then all right, so values at 0 with a reference, we give it a memory. Remember, this still complains. So vector 2D v3 equals, and the reason is that now this doesn't work at the moment because this is initialization, which means it tries to bind to the default copy constructor. So this is this translates into a call to copy constructor. Now if I don't do this, if I say first declare this, and we know that in C++ this vector to this object will be created and the default no-R constructor will be called, and then I say v3 equals values, right? So let's see what happens now. Now suddenly it works. Why? Because this line in C+ means so yeah. So now this calls to assignment operator. Whereas previously, if I say vector 2D, let's say v2 equals values, this doesn't work because this doesn't call. So this doesn't call the assignment operator, right? It calls the copy constructor. And let's maybe remove this v2 from here. And this doesn't work. The solution is to provide a copy constructor. A copy constructor is returning a object vector 2D that takes a const vector 2D const reference, right? Other, and then we're going to just do a because these are just primitive values, so other.x, and then initialize it other.y. Now the problem here is that this type is not vector 2D, so this gets complicated, but I believe this is not going to work, still not working, because it needs to first convert these values, which is a double array, to a vector 2D, which is not possible. So copy constructor doesn't, so this one doesn't work. We cannot directly do a conversion. What we can do, we can provide a constructor that takes a double array. So we can do this, double values, and then we say that values at index 0 and values at index 1. Now this works. Let me just print this out. Now this line will work because it finds a basically it finds know that this warning for unused variable, it has nothing to do with conversion. So now it finds a constructor that can be used to convert a double array to the type vector 2D. So whenever you do initialization, it tries to find a basically it has to translate into a call to constructor. But if you initialize, if you declare and then build the class with a default no-R constructor and then assign some value to it, then it tries to find the assignment operator. In Java, the construction is always explicit with new keyword, otherwise your reference is already null, and then you can overload the assignment even directly with a for example this one. So in Java, it's easy because it, instead of trying to find a constructor, it tries to find the valueOf method, and then obviously in the valueOf you just call the constructor that takes this value. So you have to be more explicit because the compiler doesn't do anything, and this is not a feature by default supported in Java, right? This is a feature that Eclipse compiler supports, and we can take advantage of it. But obviously in C++, operator overloading, especially for assignment operator or other types of operator, is built in, cooked into the language, and you can take advantage of it. So I hope you really now understand the assignment operator, how it works for user defined types and also for primitive types. Please stay tuned, and I'll see you in the next one.